This worksheet has us starting out by writing electron configurations for 3 different elements using the noble gas abbreviations. So let's take a look at the periodic table. We're going to be writing the electron configurations of lithium and sodium and potassium. To use the noble gas abbreviation, we're going to go to the noble gas that on the periodic table immediately prior to lithium. That noble gas is helium. And we'll write the symbol for that element in square brackets. We'll write the symbol for the noble gas in square brackets. And then after helium, we're just going to continue with the electron configuration. So this is the n equals 1 level, n equals 1 level. This would be the n equals 2 level. Maybe I'll just mark that. We'll need a few of these. And all of these are the s electrons. So after helium, we are in the 2s and we have 1 electron. So that's going to be 2s1. We'll do that same thing for sodium. We want to go back to the prior noble gas. That means we want noble gas with an atomic number of 10. That's neon. We put that in square brackets and then we continue the electron configuration from neon. So that is working in the 3s, we have 1 electron in the 3s, so that's going to be 3s1. And then one more of these, we have potassium. We want to go back to the previous noble gas. The previous noble gas is argon. Put that in square brackets. And then after argon, we continue with the electron configuration. We are in 4s and we have 1 electron. So this is 4s1. And the next question asks, how are these electron configurations similar? Well, they all end in something s1. So they all have some sort of noble gas and then either a 2 or a 3 or a 4, and then it says s1. That's what they are all similar, or how they are all similar. Valence electrons are defined as the electrons in the highest energy level. Remember, the energy level is the number n, 2 or 3 or 4. How many valence electrons are in each one of these? Well, the number of electrons in the highest energy level for lithium is 1. For sodium, in the n equals 3, there's 1. For potassium, in the n equals 3, there's also 1. So all of these have 1 valence electron. So that's another thing that they have in common. Now we're going to do the same thing for fluorine, chlorine, and bromine, again using noble gas abbreviation. It'll be a little bit easier because they're all on the same side of the periodic table. So for fluorine, we want to go back to the previous noble gas, which is helium. So that means we want to abbreviate He in brackets, and then we're going to pick the electron configuration up. From helium, we are in the n equals 2, and we have 2 electrons in the n equals 2, and then we continue on. Over here, this is still the n equals 2, so this is n equals 2, this is n equals 3, and these are all the p electrons. So working our way towards fluorine, we have 2, we're in the 2p, and we have 1, 2, 3, 4, 5, so that's 2p5, 2p5. For chlorine, the previous noble gas is neon. Neon, to get from neon to chlorine, we have to work our way through the n equals 3 level. We have 2 electrons in the 3s, and we have 1, 2, 3, 4, 5 electrons in the 3p. So that's 2s2, or no, 3s2, 3p5. For bromine, our previous noble gas is argon. Put that into brackets. And then let's see what we do next. So from bromine, we work our way through the 4s. There's 2 electrons in the 4s, so that's 4s2. And then we have all of these elements right here. These elements are the 3s. Remember that they are dropped down. So if this is n equals 4, then this is going to be n equals 3. If this is n equals 5, then these will be n equals 4. This is n equals 6. So these will be n equals 5. They're one number lower, and these are all the d elements. So we're working our way through these. We did 2 electrons in the 4s. And now what comes next is the 3D. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. So that's 3D10. And then from there, we are back up to the 4s. This will be 4, 5, 6, 7. So we're back up to the 4s, and in the 4s, we're in the 4p. This is 1, 2, 3, 4, 5, 4p5. How are these electron configurations similar? After the noble gas abbreviation, they are all something S2 and something P5. They don't all have the D 10, so we won't say that that's a similarity, but they do all have an S2 and they all have a P5. How many valence electrons are there? Remember, the valence electrons are the ones in the highest energy level. So for fluorine, we have a total of 1, 2, 3, 4, 5, 6, 7 valence electrons in the highest energy level. For chlorine, the highest energy level is 3, and that's 2 plus 5 is 7. For bromine, this sometimes confuses students because sometimes they just want to add all of these numbers up together and say 17. But remember, we only want to pay attention to the electrons that are in the highest N. So in this case, the 4S and 4p, that is also 7 valence electrons.